Ladies and gentlemen, I just want us to get right to it. I can see that the sun is outside. I am hoping that we are going to have a much better day compared to yesterday. Yesterday, we had a lot of disturbances in relation to the weather. So today it's shiny. Thiari, one of our assistants and one of our great behind the scenes people, was just saying that it is going to be a very great day. So I'm looking forward to this lesson, and I think all of us are going to be enjoying the lesson. All right, ladies and gentlemen, going right along, I'm moving on to the next slide. I see we've got flashes. Let me just have a look at the flashes so that I can respond to the chat box as to what it is that is going on. Remember, as per usual, we usually have an activity that we give to all of you. Then we ask that you please do that activity so that we can all be engaged in the learning to see if you understood what it is that we said. I'm quickly trying to open the chat box. Rika Sihle, I see you've raised your hand. Welcome, thank you so much. I've never seen you here before. We are glad to have you. We currently have 47 participants. That is absolutely amazing. Welcome, Kabelo. Hey, Amo, how are you doing? Amo, can you hear me? Can you please signal? I think everything is in order in terms of the audio and the video. Can you hear me? All right. Good afternoon, Malose. Thank you so much for joining us. Malose is one of our regulars. It's absolutely amazing to have him here. Thank you so much. Hi, Katu, also one of our regulars. Tyrone as well. Good afternoon, everyone. Thank you so much. Hello, all the way to welcome back. Thank you for joining us again today. All right, ladies and gentlemen, moving right along. Before we move, I just want to say that we will not be allowing video or audio questions, and that is because of the connections and also the delays that might happen. As a result, please type through any questions related to the subject matter on the chat box, and I'll respond likewise best as I can. Thank you so much. Remember, no vulgar is allowed. We are not allowed to be rude to myself or each other. If you are rude, unfortunately, Thiari will be forced to remove you, and if you are removed, you might have a problem coming back again. Remember, this platform is to assist yourselves as well as me. All right, ladies and gentlemen, the activity yesterday, we asked you to explain according to your own understanding what we mean by neutral substances. Welcome, Khomotso. Thank you so much for joining us. All right, so the explanation that I gave for neutral substances is that these are not acidic, nor are they basic or alkali. It means that they do not fall under the scale in the pH, which is 0 to 6. They don't fall under the scale, which is 8 to 14. So where are they found? They're actually found on number 7 because they are in the middle. They are neutral, hence the word suggests. So that's the question. That's the answer for question number 1. I'm hoping that all of us got it. If we didn't, ladies and gentlemen, the answer is right sitting next to you. Make sure that you correct whatever mistake that you made so that when we write the exam or the test, we are found in a better standing than other people who might have not studied like us. Question number 2, we asked you to give us the 2 characteristics of each of the following. The first one was acids, the second one was the bases. Ladies and gentlemen, I cannot overemphasize the importance of this. Remember, when we're dealing with acids and bases, some of them are extremely dangerous, and as a result, we cannot touch them. Because if we touch them, we stand the risk of either injuring ourselves or even fatality. That is an unfortunate death. So we don't want that. So each and every time we are working with these, we must be under supervision of our teachers or our parents because they are absolutely dangerous, ladies and gentlemen. All right, so the 2 characteristics of acids. Number 1, when you taste acids, they are very sour. When you feel acids, they are also very rough in terms of how they feel. I made an example, ladies and gentlemen, of the lemon juice. If you can take out the lemon juice, if it's at home in the fridge and you taste it, you realize that it tastes very sour. If you feel it, it feels really, really rough. So that's a great example of one of the things that we are speaking about there. Now, one of the reasons why lemon juice is actually very safe to consume. By consume, I mean eat and put in our teas, our coffees, or what have you, as flu remedies as we've seen at home. It's because it is alkali in terms of how it reacts. What does it mean? It means that it is soluble in water. Remember, if you take your lemon juice and you put it in tea, welcome Jonathan, thank you so much for joining us. You put it in the tea or in your coffee, it is soluble. What does that mean? It means that it dissolves in the water. And as it dissolves, it loses its concentration. So way before lemon juice is actually made, there are colorants that are added there, and as a result, it does not become so acidic. As a result, the pH scale, ladies and gentlemen, of a lemon juice is above 5. Remember what we said. If the pH scale is found on the left-hand side, if the pH scale is found on the left-hand side, meaning that 0, 1, 2, that is very, very dangerous. It's not to be touched. It is not to be consumed. But as it moves further from the left and it grows in number, meaning it becomes bigger, it loses its acidity. Therefore, it can be consumed. It's not dangerous. Hence, I'm saying lemon juice is soluble because it dissolves in water. The pH scale is above 5, meaning that it's outside the danger area. Hence, we can consume it. Hence, we can put it in our teas and in our drinks. Ladies and gentlemen, I hope you understand that. The second part is bases. We said a typical example of a base are the soaps that we use, be it the bar soaps or the dishwashers that we, unfortunately, most of us don't like doing. And I'm sure we're doing a lot of that since the lockdown and our parents are at home monitoring our every move. Ladies and gentlemen, that's also a good way for us to learn responsibility and, of course, time management. Nevertheless, let us continue. So I'm saying a great example of a household base is soap. If you taste soap, of course, I would not advise, but if you feel that you should, you realize that it tastes really, really better. That is number one. So that is the characteristic. The second thing is that it feels really slippery. Ladies and gentlemen, if you are cleaning, particularly for an example, a tiled floor and you put soap, you are likely to slip and fall if you do not wipe that. A lot of us have actually experienced that unfortunate event, maybe in the showers or in the bathrooms, and I'm hoping that we did not get hurt. But that happens because soap's characteristic is that it is very, very slippery. Now, ladies and gentlemen, remember we said from 0 to 6, that is acids. From 7, actually not from 7, 7 only, that is the neutral substance, which we said a common great example is water. From 8 to 14, that would be our basis. So we want to know, ladies and gentlemen, where do we find soaps? Soaps are found between the pH 10 to 12. That tells us that they are outside the spectrum of the area because they are beyond 7, which is a neutral. They are beyond 6, which was all the acids, ladies and gentlemen, before that. Meaning that from 8 upwards, those are your bases. So we are saying soap is found around 8 to 10. So question number 3, which was the last question, ladies and gentlemen, we were asking, what would you recommend to someone who was listening to our lesson yesterday in terms of how they can taste or rather find out if something is an acid, a neutral, or a base? So I asked that question because I wanted you to tell me. Of course, one of the ways would be to touch. One of the ways would be to feel. Again, remember the emphasis on the safety. There are some that we cannot touch, we cannot consume, because if we do, they are too acidic and therefore they are dangerous to our health. They might cause us injuries, fatalities, or God knows whatever else. So the safest way to do that would be to use indicators. Ladies and gentlemen, so indicators, that's what we are going to be talking about today. So one of the answers that I expected was that we use indicators, which tells us the acidity or whether something is a base or whether something is a neutral. Let's have a look at the questions. Dorica says he skates on the soap on the floor. Yes, Dorica, that is because the soap is very slippery. I wouldn't advise though, because you suffer the danger of getting hurt. So yes, but you're absolutely right. That is absolutely correct. Okay. So I'm just going through some of the questions that are there. Welcome everybody else. Thank you so much. Marika says they are also learning about acids that are found in the body. Absolutely. Particularly in the digestive system, Marika, that is useful because those acids are the ones that break down food. Remember, if you eat an apple, Marika, the state of the apple is a solid because it's hard. When you chew it, you obviously change that and it becomes somewhat of a liquid. But when it goes into your body and it's transferred to different parts of our bodies and the nutrients are also distributed accordingly in our digestive system, the acids are important in that respect, Marika. That is an absolutely great question. However, the question is actually very good for high secondary school when you study what we call biology in our time, donkey years ago. Now it's known as life sciences. Thank you so much. All right. Malosa is asking why we get goosebumps and shiver when we drink something sour. And I'd like to extend that and say even something that is bitter. Remember, Marika, yesterday, we learned about the tongue taste areas. And when we learned about that, welcome, Tabi, saying thank you so much for joining us. So when we learned about the tongue and the taste buds in the tongue, remember we said they are found at the top, they are found on the side, and even underneath. Now, what happens is that when you taste something, those taste buds takes whatever taste you have into your brain, and then your brain tells you if something is sweet, sour, salty, or bitter, and then your body reacts likewise. So if something is sweet, those taste buds tell your mind that something is sweet, and therefore you have a certain enjoyment, and therefore you don't shiver. So you consume a chocolate without even stopping. Welcome, Lono. Thank you so much for joining us. However, if you are consuming a lemon or you're consuming salt, you start to shake a bit. That is because your body is reacting to the taste that you are tasting in your taste bud. I hope that assists. Thank you so much. Okay. Thank you so much. Just to be clear, ladies and gentlemen, we've learned about the human body in one of our first lessons. I think it was lesson number 2, but we only learned about reproduction. If you feel you need to have a look at that, it's available on YouTube. It's also available on the African Teen Geeks website for you to have a look at. But for now, ladies and gentlemen, what we are doing is that we are continuing with acids, neutrals, as well as bases. Thank you so much, Dorika. Reproduction was done. Continuing and moving right along. So today, what is it that we are doing? Number 1, Nonhlanhla, welcome. Thank you so much for joining us. We are looking at acid-base indicators. Remember in the previous exercise, I asked you to say, what would you recommend to someone who wants to test whether something is a solid, acid, or a neutral? So we are looking at acid-base indicators. We are going to study about litmus papers. The last thing, we are going to investigate common household substances by finding out whether they fall under neutrals, acids, or bases. So those are our 3 objectives. That's what we want to achieve by the end of the lesson. All right. Questions to think about. Now, these are just for us to remind ourselves or to set a certain ground level to find out where we are in terms of our understanding so we can be able to build on that. The first thing, how is it that we determine if something is an acid, base, or a neutral? I will go back to the lesson objectives. The answer is right there, staring us in the face, ladies and gentlemen. Number 2, what are litmus papers? We might not know, but one thing that I think we can deduce from that is that these are papers. We'll find out how they work and what it is that they actually do. Number 3, when you are investigating all of these common household substances, I want you to think about this. Right now in your homes, what can you think about that is an acid, that is a base, that is a neutral? Except the lemon juice that I gave as an example of an acid, except the soap that I gave as an example of a base, and of course, except water, which is a common neutral substance. What other substances can you think about, ladies and gentlemen, as we move? Before I move on, I see the chat box is really flashing. Thank you so much, Chanel. Vinegar is a great example. Mutsuedi, you're absolutely correct. Vinegar is a great example of acid as well. Ladies and gentlemen, I'm absolutely impressed. It means we learned something from yesterday. This is amazing. Sweets, I'm confused, Ranzu. Where do sweets fall under? Where does sugar fall under as well? Let us revisit one of those answers. Remember, when we speak about sugar and salt, we are speaking about how something tastes. We are not necessarily speaking about substances that speak to those. All right, let us move right along. Ladies and gentlemen, before we move, I want to have this for a revision purpose for the people that are joining us today that were probably maybe not here yesterday. This is also going to assist us because we need to understand the pH scale when we move on into the acid-base indicators. So moving to that, we are revising this. This was done yesterday. So remember we said the pH scale is used to measure how acidic or how basic something is. So that's what it does. So at the bottom, I'm just moving the cursor. There is an example of a pH scale. It can come in many forms or ways. However, ladies and gentlemen, we need to know that the acid is found on my left, and then the alkali or the base is on your right. And remember, the neutral, as the word is implying, is in the middle, and that is number 7. So acid would be 0 to 6, base would be 8 to 14, neutral would be 7. Ladies and gentlemen, I've spoken about that. As a form of example, again, an acid example would be lemon juice. A base example would be soap in any form. By form, I mean the bar soap that we use when we are bathing. That is our green, for example, a sunlight bar, or it can be liquid, also the liquid sunlight bar. Of course, here, ladies and gentlemen, your jigs also fall under this category. Your bleaches also are found in this category. And an example of a neutral, as I've been saying, is water. Let me just have a look at this. You are new to this. Let me see who that is. Welcome. We are very glad to have you. It's Dorica. Thank you, Dorica. We are hoping that you are going to enjoy. Welcome, Dalen. Okay. An alkali, to answer you, Mutswedi, is a soluble base. What does that mean? It means that it dissolves in water. So an alkali can be seen as a base. Remember, solubility means something can be able to dissolve where? In a liquid. So if something dissolves in a liquid, it's a soluble. And what is a liquid? If you remember from when we're introducing properties of matter, a liquid is called a solvent in natural sciences. Welcome, Figile. Thank you so much for joining us. We are hoping that you're going to learn something and you're going to enjoy yourself. Thank you so much for joining us. We are pleased to have you here today. We are currently sitting on 62 participants. That's absolutely amazing. So let us investigate these litmus papers that I'm talking about. Okay, so acid-base indicators. Ladies and gentlemen, what are these? As the word is saying, these are to indicate if a substance is a base or if a substance is a neutral, or as well if a substance is, of course, an acid. So acid-base indicators simply tell us if something is an acid, a neutral, or a base. Ladies and gentlemen, the most common of these that are used particularly at school is what we call litmus papers. So we have what we call the red and the blue litmus paper. I'm just moving the cursor around those two so we can see. So we've got the red litmus paper, we've got the blue litmus paper. Now remember, if you want to taste a substance, that substance needs to be in liquid state. What does it mean? You cannot take a litmus paper and put it on a bar soap that is not wet. The bar soap needs to wet so that you can see the reaction. Now, what we are saying is that these red and blue litmus papers change color or do not change color depending on whether something is an acid or whether something is a base or whether something is a neutral. Ladies and gentlemen, we'll go into that. So again, just to recap, indicators are substances that are used to tell us whether a substance is a base, a neutral, or an acid. Now, in the school level, the indicators that we study are blue and red litmus papers. I've put a picture right there at the bottom. Now, we use these to taste whether something is a base, a neutral, or an acid. Now, remember that substance must be in liquid state. So it means that it needs to be in the water state. I see the chat box is also flashing. Let me have a look. Okay. Let us have a look at some of the questions that are there. I can see that Mutswedi is asking Tabi saying not to be rude. I missed that message. Ladies and gentlemen, like I said in the beginning of the lesson, let us try our best to be calm. Let us not frustrate each other. Let us respect each other, ladies and gentlemen. This is meant to assist all of us. As I've said, if you are found to be rude or foul or vulgar, you will be unfortunately removed from this platform. You will not be able to join us again. Jonathan is asking about oxygen. Jonathan, we are going to be doing what we call the periodic table of elements. When we get there, we are going to study those. Katu, we are going to look at that. Let us read, ladies and gentlemen. Okay, moving right along. So let's look at the litmus paper changes. So what happens when a litmus paper is coming into contact with an acid, a base, or a neutral? Remember I said the litmus paper comes in two colors. It comes in the red as well as in the blue. But remember, the pH scale of substances is in three forms. It comes in an acid, a base, or a neutral. I want us to start with the acid. So if you are testing an acid, let me make an example. So you have yourself a liquid state Obviously, lemon juice. So you've got lemon juice here. Let's imagine instead of the water that I have here. Unfortunately, I don't have lemon juice in my house. So you've got lemon juice, and then you take a red litmus paper, you put it or tip it a bit. Ladies and gentlemen, if you can have a look, just have a look here. So you tip it a bit. Remember, the litmus paper is red. You put it in what? In lemon juice. What's going to happen is that that red litmus paper will not change color. The reason it does not change color is because the red litmus paper will be indicating, remember, litmus paper is an indicator, will be indicating to you that the lemon juice that I'm giving as an example is an acid. So it will remain red. Let me repeat myself, ladies and gentlemen. We have got a red litmus paper in our hands. I'm moving the cursor on the right-hand side of the picture there. So in the red litmus paper, you put the red litmus paper, a tip of it onto lemon juice. It's red. The color red will not change. So what does that mean? It means that red litmus paper in acidic substances remains red or does not change color. Then we go on to the red litmus paper when we want to test if a substance is a base. Let me use an example. So we have made ourselves a solution of water and soap. So we take soap, we put it in a bit of water, we shake a bit, meaning that we're mixing the soap and the water. Remember, that's what a solution is, a mixture of two substances that then combine and become one. We then put the soap aside, then we've got a solution of soap and water. We then take a different litmus paper, which is red in color, we put it in the soap. What will then happen? The red litmus paper, ladies and gentlemen, will change color from red to blue because it will be indicating that the solution of soap is not an acid, it is a base. So if you take red litmus paper and put it in a basic substance, it changes color from red to blue. Then we go to neutral, ladies and gentlemen. So you take the red litmus paper. I wish I had litmus papers here with me, but I do not. Luckily, we've got a video for this. You put it in water, which is a neutral substance. That red litmus paper, ladies and gentlemen, will remain red. It will not change color because the substance is a neutral. Example, water that I have here. We then move to blue litmus paper. So we take blue litmus paper, we put it in a substance. I see that we've got participants that are raising their hands. Ladies and gentlemen, I am going to answer and respond to those questions. So we take that blue litmus paper, we put it again, the similar example that I used, in lemon juice. That blue litmus paper will change color from blue to red to indicate that the lemon juice is in fact an acid. So you take blue litmus paper, put it in an acidic substance. For an example, lemon juice. I'm using lemon juice for consistency and also to avoid understanding. Of course, even in vinegar, you'll get the similar result because that is an acid. So you put it inside your acidic substance, which is lemon juice. That blue litmus paper will change from blue to red. Now we take the very same blue litmus paper, we use the same solution of soap and water that we had. When we put that blue litmus paper in that solution of soap and water, it will stay blue. The reason why, it's because it will be indicating, remember, litmus papers are indicators. They indicate or tell us whether something is an acid, a base, or a neutral. So it will stay blue to indicate that that substance, which is a solution of soap and water, is in fact a base. Now, if you take a blue litmus paper again, you put it inside water, it will not change color because that water substance, this one, is a neutral substance. It is not acidic, it is not basic. So ladies and gentlemen, just to recap, if you want to easily understand this, red litmus paper, remember red is for danger, is telling us, so if the color remains red for red litmus paper or changes from blue to red, it is telling us that something is acidic. Remember, as I'm saying, red is associated with danger. It means stop, it means something is dangerous. So it will remain red if it was red, or it will turn red if it was blue. What then happens to blue? Blue is a color that is actually associated with the sky. It's safe, it's good, it's fun. We all love the color blue somewhat. All right, so now if something is basic, if it was red initially, it will turn to blue. However, if it was blue inside a base, it will remain blue. However, neither red or blue change color in a neutral substance such as water. Ladies and gentlemen, the two pictures are showing us that, number one, an acid turns blue. So basically, if you look at the tip of this litmus paper, it was what color there? It was blue. So you tip it here. I'm assuming that because of the color, that would be vinegar. So now what happens? It changes the state from blue to what color? To red, because it's showing us that this is an acid. Going to the second picture, I'm moving the cursor on our right, my right, I'm assuming your right as well. So the red litmus paper would be put inside. When it's put inside, the red will turn blue. So again, that would be, for an example, a solution of what? That would be a solution of soap as well as water. It would then change the red litmus paper to blue. I have a video, ladies and gentlemen, that I would like to show you. This is natural sciences. Of course, would love to have a practical investigation of this, but unfortunately, because of resources, we have to resort to explanations. But luckily enough, because of the internet, we have pictures. So let me just show us a video so that we can see what it is that we are talking about. Excuse me. Let me share a different screen. Bear with me. All right. Apologies, ladies and gentlemen. This will only take a second. Please, I apologize again. The video, unfortunately, is not in English. I've then muted the audio so that we can be able to just look at the pictures. But in between that video, I will be explaining and pausing so that we all understand what is going on. Okay, I'm not sure why it's not playing. Okay. All right, there we go. So the first one is an acidic solution. If you look at that litmus paper, the color is blue. Remember I said the acidic solution, ladies and gentlemen, can be vinegar or it can be lemon juice. Remember we are using these because these are household, easy to understand example. Of course, we've got your hydrochloric acid, which are very dangerous. Those are used to make batteries. We are not to touch those. Those, ladies and gentlemen, are absolutely dangerous. So as you can see, in this illustration, blue litmus paper is put in an acidic solution, and I'm saying maybe that would be lemon juice. We are making an example of vinegar. That blue litmus paper will change on the tip where it was entered, and it will change to the color red to indicate that the vinegar or the lemon juice is actually an acid. Excuse me. The second picture there is the litmus paper is red. So the solution there, again, let's just say the solution is a mixture of water and a soap. Therefore, the red litmus paper at the tip will change its color and become blue. Again, apologies for the audio. This video, unfortunately, is not in English, so it was going to confuse. Hence, I have to speak through the video. What's going on, Tabi saying, is that we are having a video that is showing an experiment of testing whether something is an acid, a neutral, or a base. That's what's going on. We are doing this because we do not have these resources at our disposal because of the lockdown. So we are just using the video to show what is going on. So again, there is a base solution. Basic is simply base. Remember, we can also say it's alkali. So they're also showing us there a different version of that. Bear with me for a couple of seconds and then we'll then continue with our lesson. All right, so thank you so much, ladies and gentlemen. I am hoping that the video was able to somewhat explain what I was hoping to be explaining, that red litmus paper remains red in an acid. However, red litmus paper changes to blue in a base. Blue litmus paper changes to red in an acid, remains blue in a base. However, both red and blue do not change when they are put in a neutral substance such as water. Ladies and gentlemen, let us continue with our PowerPoint presentation. Thank you so much for your patience in that regard. All right, so we are passing that slide. Now, there is an interesting fact of nature that I thought it might be interesting also to share. I am also one of the people that learned about this when I was doing research for this lesson. Ladies and gentlemen, red cabbage, the one where I'm moving the cursor around, the one that is below the green normal cabbage that we know. So red cabbage, ladies and gentlemen, is one of the things that can be used as an indicator. So if you look around, in a lot of instances, red cabbage we see being used in salads. Maybe I should have had a nice picture of that, and all of us would have actually wanted to consume that salad, even though it would be in picture state. Nevertheless, so red cabbage contains a pigment. A pigment is just a scientific fancy word for color. A pigment that is soluble, which means it dissolves in water. Now that pigment is called flavin. Ladies and gentlemen, this is just for your interest, just to know that if we do not have blue or red litmus paper like we don't now, like I say, as I was doing research, I also learned about this. If we go into our fruits and veggies and we are lucky enough to get this type of a cabbage, which is red, we can actually make our own indicators. How do we do that? Number one, we cut certain pieces of the cabbage. We then boil it for a few minutes, not more than 10 minutes. We then only drain or take out what? The liquid, of course. We don't need the leaves. Then what do we do, ladies and gentlemen? We put it in different sets of glasses, if I may. Then we then put in what, if you want to test, for an example, whether, and so let me just explain. So we take the cabbage, we boil it for a couple of minutes, that's like 10 minutes. After boiling it, we drain and leave out the leaves and only have the liquid. Then we put it in different types of containers. Then maybe we want to test if something is an acid. And again, we take lemon juice. We take the lemon juice. When we put the lemon juice droplets inside the red cabbage solution that we have made, we will find that the color, ladies and gentlemen, will be red, purplish blue in color. So it will be around here to show us that the lemon is in fact an acid. However, if we take a solution, so remember I said we make that solution, we put it in different glasses or different petri dishes because we are testing it. So then we then take a solution of soap. When we put that solution of soap and water combined together inside that cabbage indicator, which is red in color, that we will find that it will then change color into yellow. Something to look at, ladies and gentlemen. Go crazy, research it, find out. When, like I say, when we go into our fruits and vegetables, let's have a look at that and see what happens. All right. So what are our takeaway points for today's lessons, ladies and gentlemen? Number one, indicators are materials that are used to test if a substance is an acid or if a substance is a base. I said one of the common indicators that we use in classrooms, in our scientific experiments, are what we call blue litmus papers. But also remember, cabbages are also, particularly red cabbages, once we take leaves out of it and we boil it for about 10 minutes, we drain out the water, can become an indicator, which means it's going to indicate or tell us if something is an acid, a base, or a neutral. I've explained number two as well about the red and the blue litmus papers. Those are our takeaway points. The last one, indicators change color if something is an acid or if something is a base. We said if you take a red litmus paper and you put it inside an acid substance, it will remain red. However, if you take a red litmus paper and put it in a base substance, it will change from red, to blue. If you take a blue litmus paper and put it in an acid, it will change from blue to what? To red. However, a blue litmus paper, if it is taken and put inside a base, it will remain blue. Both red and blue litmus papers do not change when they are put in a neutral substance such as water, ladies and gentlemen. So there is our activity that I want us to do. The last objective of this lesson, remember I said we want to investigate the certain common household substances that we use every day, and we want to find out if they are acidic or if they are basic. Okay, I'm just going through our chat box to find out if there are questions that are here. Very long message from Talia. Okay, again, ladies and gentlemen, she's simply just emphasizing that we all need to come down, we all need to respect each other so that we might be able to benefit from this. Let us try our best, ladies and gentlemen, under very difficult times and circumstances. Thank you so much. So I want you to do this as an activity. I had asked, and I remember Malosa yesterday said this, that he took a picture of this. So if you can take a picture, if you cannot, take a screenshot, or simply go to the African Teen Geeks website or the YouTube African Teen Geeks channel to find this activity. But what are we doing, ladies and gentlemen? We are testing whether something is an acid, a neutral, or a base. What is the something that I'm referring to? The substances there are lemon juice, vinegar, water, and soap. So what are we doing? We are testing this. So now, how do we do that? We need to find out the taste. Is the taste or is the taste sour? If the taste of lemon juice, ladies and gentlemen, is better, you will simply tick to indicate. If the feel of lemon juice is slippery, you'll simply tick to indicate. From those two, the taste and the feel, you must then tell us if it's an acid, a base, or a neutral. So basically, we are investigating the properties of these four substances so that we can then be able to make a decision on our own. So we are actually doing a practical investigation on our own at home using these substances. Some of these we can, of course, use the internet, but as I say, it would be nice for us to try them out at home. So let's take pictures, let's take screenshots, or let's watch the video again and then do the activity. Okay. Ladies and gentlemen, like I said, let us try our best to do this at home so that we can be able to revise them tomorrow as corrections and find out where we are. Let us remember in our responses on social media platforms to hashtag lockdown is school in our responses so that all our friends can also be able to join us in our next lesson. These are simply some of the links wherein I used to prepare this lesson for you. There are certain videos there. If you feel you want to go and explore, you are more than allowed, ladies and gentlemen, to do that and study at your own time. What is it that we are doing tomorrow? Someone was asking about oxygen, and I had responded that oxygen is an element, and then elements are found in the periodic table. So tomorrow, we are going to be doing the elements of the periodic table, but we are doing an introductory lesson of that. So looking forward to it, not an easy lesson, not lesson per se, but not an easy topic, but I'm sure most of us are going to actually get it. Let me go through some chats. I see there are flashes that are there. Okay, goodbye. Thank you so much for joining us. Remember to do the activity. Ladies and gentlemen, please follow us on social media. Like I said, let's hashtag lockdown at school, at African Teen Geeks, at iZora, at DBE_SA, Sasol Foundation and Sasol SA, who is one of our sponsors, and of course, hashtag STEM Champions. This was a great lesson. Thank you so much. The network was not bad. Let us remember to do the activity. I will see you tomorrow when we do the introduction into the periodic table. Enjoy your next lesson and the rest of your day. Thank you and goodbye.